Hi everyone, welcome back. So let's start with our first example. And well, our prof told us that's the only example that we should know for the exam. But you can try more examples. But here it is. So I'm gonna phosphorylate a tyrosine residue. Tyrosine residue. So let's draw the structure of tyrosine. Um, so I have my carbon, hydrogen, carboxylic acid group, NH2, and then CH2, benzene ring, and then OH. Alright, so I need to phosphorylate it. The enzyme that is usually used for adding a phosphate group is referred to as a protein kinase. This protein kinase uses an ATP molecule, so that's where the extra phosphate comes from, and converts it into ADP. So it loses a phosphate group, and that phosphate group is added to the residue. So let's draw the structure now, what happens to it. So CH2, and then I have my benzene group here. That hydrogen basically gets replaced, so negative, negative, and then a double bond O, with that phosphate group. So here is my phosphate group that came from the ATP molecule. Okay, so it has this protein kinase molecule has added that phosphate group onto the amino acid residue and replaced the hydrogen with it. And then of course you guys know the rest of the structure is still the same. Now, like I said, these covalent modifications are reversible. So I can, reverse this reaction, and the enzyme that removes a phosphate group is referred to as a phosphatase, and it just uses a water molecule because we need to now replace that hydrogen that we lost here. So we need to replace that. So that hydrogen comes from this water molecule, and this water molecule is basically, well, the overall reaction is that you get your inorganic phosphate molecule back. So this phosphate molecule is going to come off. Alright, so this is a general scheme of how phosphorylation works, right? You can try it for serine, and you can also try this for threonine. Okay, but the two most important things that come out of this is protein kinase and protein phosphorylation. Protein kinase and phosphatase. So protein kinase is something that adds a phosphate group using an ATP molecule. And a phosphatase is something that removes a phosphate group, okay, using water. So this is like the general idea. Now the protein modifications of this kind are not restricted to just proteins. You can have modifications happening to another group of molecules called phosphoinositides. And we will talk about them a little later, but you can have modifications happening to these phosphoinositides as well, and they can create a limitless set of molecules or structures just using those modifications. Alright, now I don't think we can finish this off, but let's just start with our next topic, which is the protein kinase phosphatase cycle. Now I've talked about this already a few seconds ago, and these protein kinase and phosphatases, they basically act as molecular switches, and I think you guys understand now why. They are reversible modifications. Phosphorylation is a reversible modification. So if I need a protein in its modified form, in its phosphorylated form, I just get a protein kinase to act on it. If I need to take the phosphate group back, I get a phosphatase to act on it. So they basically act as molecular switches. So you have your dephosphorylated protein, and you add the protein kinase to it, you'll get your phosphorylated protein. If I get a phosphatase to act on it, then I get my dephosphorylated protein again. And so it's like a molecular switch basically. Okay. Alright, so in the next one we'll get into the history of protein phosphorylation, and we'll take it from there. Thanks so much.